The radiation from such flares could potentially disrupt the atmospheres of planets orbiting close to them. Now, this doesn't mean that Wolf 359 is actively cook any potential life on a planet and generally wreak havoc on a fragile ecosystem. This is particularly true for planets that are closer to the star, where the radiation is more intense. Earth, of course, is far enough from Wolf 359 that we don't need to worry about this kind of radiation disrupting life here. But let's take this one step further. Can stars ever really eat planets? Stars, in the way we typically imagine them consuming something, don't actually eat planets in the sense of engulfing them whole. What does happen, though, is that when stars end their life cycles, they can expand and take out anything in their immediate vicinity. For example, our own sun will eventually expand into a red giant, which will likely engulf the inner planets, including Mercury, Venus, and possibly Earth. This process, known as stellar evolution, is inevitable for stars like ours. But it's important to note that this is a natural part of the life cycle of stars, and it's something that happens over billions of years. It's not a violent, sudden swallowing. What does this tell us about Wolf 359? Will it ever swallow anything? Well, considering its current size and its place in the universe, Wolf 359 will likely remain relatively stable for billions of years to come. However, in the distant future, as stars evolve and the universe continues and interactions, if Wolf 359 were to somehow explode in a supernova or go through some dramatic stellar change, it could send out waves of radiation and particles that would affect nearby celestial bodies. But for now, it's not a star that's actively on a collision course with Earth. So, we've explored a few what-if scenarios, but let's finish with a reality check. While stars like Wolf 359 aren't going to consume Earth, we do have to be mindful of the real cosmic threats. There are examples in our own galactic backyard of stars that could come closer to us in the future, like Gliese 710. This star is predicted to pass within 1.3 light-years of the Sun in about 1.3 million years. While this won't lead to any catastrophic collisions, it could certainly disrupt the Oort cloud, sending icy objects toward our solar system and maybe even altering the orbits of planets. It's a reminder that while the universe is mostly peaceful, there are always possibilities for surprises. It's worth keeping in mind that stars, like the mysterious Wolf 359 threats we sometimes imagine, but they do provoke important questions about the future of our planet, our place in the cosmos, and the forces of nature that shape the universe. So while we're not in any immediating to look up at the stars and wonder, what's really out there waiting to surprise us? As we venture deeper into the cosmic realm, there's a fascinating idea that keeps coming up. Could there be life around a red dwarf star like Wolf 359? It's a thought that sparks the imagination. After all, red dwarfs are the most common type of star in the universe. In fact, roughly 70% of the stars in our galaxy are red dwarfs. With such a dominant presence, the possibility of habitable planets orbiting these stars is not just intriguing, it's almost inevitable. But what would life on such planets look like? Could anything truly thrive around a red dwarf, especially one as unique as Wolf 359? First, let's take a look at what habitable means in this context. When scientists talk about the habitable zone, they're referring to the region around a star where conditions are just right for liquid water to exist, a crucial ingredient for life as we know it. Now, here's the catch with red dwarfs. Their habitable zones are much closer to the star compared to our Sun. Since red dwarfs are smaller and cooler, their habitable zone exists much closer to them, potentially making the planets in these zones far more vulnerable to other types of dangers. For example, imagine a planet orbiting a red dwarf star, right in the sweet spot where water could exist as a liquid. Sounds perfect, right? But there's a hidden twist. Because the planet is so close to its star, it could become tidally locked. This means one side of the planet always faces the star, while the other side remains in perpetual darkness. On the star-facing side, temperatures could rise to scorching levels, making it a molten, boiling wasteland. Meanwhile, the dark side would be locked in an eternal frozen night, potentially colder than any place on Earth. This makes life, as we know it, very unlikely on either side, unless it's somehow adapted to these extremes. But let's entertain the idea for a moment. What if life could adapt to these conditions? After all, life on Earth has proven time and time again that it's adaptable. From the deepest ocean trenches to the driest deserts, life finds a way. So, maybe, just maybe, some form of life could evolve on the twilight ocean and the challenges of a relatively small habitable zone. But here's another twist: predictable behavior. In fact, they tend to have flare storms, intense bursts of radiation that can wreak havoc on anything living on planets around them. Wolf 359 itself